Alright, welcome to iChem Lesson 18 from Unit 8. This is your last unit, so let's push through till the end. Alright, so the beginning here we're going to talk about some definitions. The first definition is this idea of concentration. So, what is concentration? We communicate the difference between concentration using the idea of dilute and concentrated. So a dilute solution would have few particles, and a concentrated solution would have many particles within a volume. Okay, we sort of talked about that today in the idea of solubility. We had a certain amount dissolved in a certain amount of something else. That's the idea of concentration. We communicate the level of concentration in terms of these specific calculations or numbers. The first one would be molarity. This is our most common, used in many other equations. The symbol for molarity is a capital M. I'll let you get some of that down. So most common, useful in many situations, and its symbol is capital M. The equation for molarity, this is the most important thing to get down here. Molarity equals the moles of solute over the liters of solution. Moles of solute divided by liters of solution. Remember there, solution is the solute and the solvent together. It's a simple ratio of solute to solution. We represented ratios a while back using this triangle. We have a density triangle. Let's draw a molarity triangle. You have one on your sheet. So if you draw the crisscrosses in like this, and then we'll add our definitions, right? So molarity, capital M, we're going to put in this bottom left corner. Its definition is moles divided by liters. So if we wanted to find molarity, remember how these work, we would cover up molarity and see that we would do mole divided by liter. Say we were looking for mole. If we cover up mole on the triangle, my pointer's not huge here to cover it up, but we cover up mole on the top here, you could see that if you wanted to find moles, you would multiply molarity times liters. And then finally, if you wanted to find liters, cover up liters, you would do moles divided by molarity. This sort of takes the algebra out of it if you can remember the triangle. Okay, so molality. This is less common, and it's useful in really only one other equation. The symbol is a small m. The definition for molality is moles of solute per kilogram of solvent. So it's really different here. The numerator in both of these is the same, but the denominator is different with kilograms of solvent. It's a ratio of solute to solvent here. We can draw the same triangle with slight modification. The small m goes in the bottom left because we're trying to find molality. Moles goes on the top again, but now in the bottom right we have kilograms. And this triangle works the same way as before. If we wanted to find molality, we would cover up that m and see we would do moles divided by kilograms. Let's just do some examples.
Alright, so let's start with some molarity examples. In the first example, we're asked what's the molarity of a 150 milliliter solution containing 22 grams of sodium chloride. If I want molarity, I'm going to cover up the M. Remember these triangles? The definition of molarity is moles per liter. So I'm going to divide moles by liters. To be able to do that, I need moles and liters. Here I have 150 milliliters. We need to convert that to liters. That's 0.15 liters. Just divide it by 1,000. Here I have 22 grams of sodium chloride. I need to convert that to moles. So I start with 22 grams. I want grams on the bottom, moles on the top, and I need the molar mass of sodium chloride. Sodium is is 23 approximately, and chlorine is 35.5. You get 58.5 grams per mole. Okay, so if I divide 22 by 58.5, I get 0.376 moles. Okay, now I have moles and liters. I can apply my definition of molarity. Molarity is moles divided by liters. I get 2.5, and then we say molar with a capital M. Let's do another example. I want to know how many grams of HCl are needed to prepare a 200 milliliter solution of 0.5 molar aqueous solution. Okay, so I want grams. That's not part of my triangle, but moles is. So from here, I'm actually going to find moles. So I want moles. I cover it up. What I'm going to need to do is multiply molarity by my liters. Before I can do that, I need liters. So instead of 200 milliliters, I have 0.200 liters. All I did was divide by 1,000. Now to get my number of moles, I just want to multiply that number. See? Moles times liters, multiply that number by 0.5 molar. When I do that, I get 0.1 moles. Okay, I have 0.1 moles. I want grams of hydrochloric acid. I'm going to take 0.1 mole. I'm going to multiply by the molar mass of hydrochloric acid, which is 36.5. 0.1 divided by 36.5, I get 3.65 grams of HCl. Okay, so now let's do some molality examples. Molality is the little m. Okay, so what is the molality of a solution containing 25 grams of water and 15 grams of NaCl? Okay, so let's say 25 grams of water, 15 grams of NaCl. The hard part of these questions is sort of figuring out which one of them is your solvent and which one is your solute, because in both you're given grams of each here. Okay, so I have 25 grams of water and only 15 grams of NaCl. So water is going to be my solvent. Pretty much anytime you see water, it's a good bet that that's your solvent. So if I want molality, if I come to my triangle here, I cover up my M, it's moles divided by kilograms. It's moles of solute over kilograms of solvent. Okay, so for my solvent, I want it in kilograms. I have it in grams. I want to divide that by 1,000. So 25 grams divided by 1,000, 0.025 kilograms of my solvent. Alright, I want moles of my solute. My solute is sodium chloride. I have it in grams. To be able to use it, I want it in moles. So I use my molar mass. We found the molar mass of sodium chloride on the previous problem to be 58.5. So if I do 15 grams divided by 58.5 grams per mole, I get 0.256. That goes here, that's my moles. 0.256 moles. And moles per kilogram. I get 10.2 0.25, and then little m, molal solution. So big M we say molar, little m we say molal. Okay, one more. So we want how many grams of hydrochloric acid are needed to create a 0.25 molal solution with 50 grams of water. Okay, so water, I see water, I'm going to call water my solvent. So I'm going to take the 50 grams and I'm going to divide that by 1,000. I get 0.05 kilograms of water. And what I'm looking for is the moles. This equals 0.25 molal solution. I didn't use a triangle this time as much as the definition. Moles per kilogram equals molality. See, it's sort of set up like this one, except my unknown is a little bit different. I could have said, okay, I'm looking for moles. I want to do molality times kilogram, which algebraically is what I would do here to get how many moles. I would get moles equals 0.05 times 0.25. Okay. I get 0.0125 moles. And in reality, what I want is grams, so I'm going to convert that using the molar mass, which we found in the other problem to be 36.5. Okay, so now we end up with 0.456 grams of hydrochloric acid. So I identified my unknowns. I either set up algebraically using the definition moles per kilogram, or I used my triangle. I'm looking for moles, molality times kilogram gives me moles. Once I have moles, I can find my molar mass. There's one more kind of problem, and these are called dilution problems. If you're ever in a situation, well, this is basically in the lab how it works all the time, you have a more concentrated solution than you need. Okay, so we need to do an experiment in a situation. We need to do an experiment using 100 milliliters of 0.1 molar hydrochloric acid. The stockroom contains plenty of 0.5 molar hydrochloric acid. Can you make the 0.5 molar solution work? And the answer is yes, you can dilute it. When I say dilute, I mean add solvent. So in this case, add more water to increase the volume. So we have this handy equation, M1V1 equals M2V2. This is our initial concentrations, and this is our desired, our final concentrations. So we want, in the end, our final concentration to be 0.1 molar, okay? And we want 100 milliliters of that. The question becomes then, how many milliliters of this 0.5 molar solution do we need then? So my initial concentration is 0.5, and I'm looking for how much of that I need within that total of 100 milliliters in the end. So to solve for V1, I just want to divide both sides by 0.5. V1 equals 0.1 times 100 divided by 0.5. I get 20 milliliters. So to make this solution, I would take 20 milliliters of my 0.5 molar hydrochloric acid and dilute it to end up with 100 milliliters total of 0.1 molar. So in reality, I would take this 20 milliliters of hydrochloric acid, dilute it to 100, which means add 80 milliliters of water, and I would end up with a 0.1 molar hydrochloric acid solution. We'll do more of these tomorrow. Don't forget to do your Google Form.